All right, this is the last 10 problems. So starting with 41, we have 2 tangent theta over 1 plus tangent squared theta equals 2 sine theta cosine theta. So I'm going to start on the left side for this one because I see a Pythagorean identity right away. So I'm going to make this 2 tangent theta over secant squared theta. And at this point, I want to rewrite in terms of sine and cosine. So 2 times sine theta over cosine theta. And then instead of divided by secant squared, we can say times cosine squared theta over 1. And because all of this is just multiplication and division, we're allowed to cancel out this cosine in the bottom with 1 on the top. Those divide out to 1. And we're left with 2 sine theta cosine theta. For 42, for number 42, just this here. This one starts out saying that 1 plus cotangent theta over cosecant theta is equal to 1 plus tangent theta over secant theta. So I don't think it matters which side you start on really for this one. So I'm just going to go left. So no identities here. 1 plus cotangent is not equal to cosecant. That's not a Pythagorean identity because it's not squared. So this is going to get rewritten in terms of sine and cosine. So 1 plus cosine theta over sine theta over cosecant, which is 1 over sine theta. I've got a complex fraction here, so I want to efficiently clear out the complex fraction by multiplying by sine theta over sine theta, because that is what the only trig function that I have in the denominators throughout the whole thing. So when you do that, in the numerator, you get sine theta plus just cosine theta. In the denominator, you get just 1. So this is kind of weird. We just have sine theta plus cosine theta. Well, let's look at what we're trying to get. We're trying to get 1 plus tangent theta divided by secant theta. So maybe we say, well, if I want to get a divided by secant theta, maybe I multiply by a secant theta as well. So let's do another multiply by a special case of 1 here. We've had this trick before where maybe we had something more of a complex fraction and we said, well, let's multiply by 1 over cosine or 1 over cosine. So same idea, just saying, well, I want to have this in here, so I'll put it in there. And I just have to balance that out by multiplying by the same thing on the top. Okay, so what does that get me? Secant times sine, or sine times secant, plus cosine times secant, all over, this is over 1, so secant times 1 is all over secant. So we're back to having a fraction. And then let's look at this. Sine times secant is the same as sine times 1 over cosine, or we can just make that sine over cosine. Cosine times secant is cosine times 1 over cosine, or that's just 1. You can write that as well. And I'm going to leave the secant as it is because, again, looking at the right side of the equation, I want to keep that in my answer. Let's see, we're trying to get 1 plus tangent theta. So we have 1 from this term, and sine over cosine is tangent. So let's write it in the order that matches the proof. Let's put the 1 first, and then the plus tangent theta, all over secant theta. That's not the only way to get there, but that's just the way that I thought of for this one. All right. Let's see. Our next problem is 43, right? Yeah, we're on 43. So 43, I see some higher exponents. 1 minus cosine to the 6th of theta over sine squared theta is supposed to equal 1 plus cosine squared theta plus cosine to the 4th theta. All right, so higher exponents indicate factoring. And really, this could be a difference of squares or a difference of cubes. But if I did a difference of squares, that's not going to help me much. Difference of squares would look like this. And I don't see anything about cosine cubed over here, so I don't really want to mess with that. Instead of difference of squares, I'm going to go difference of cubes. So the difference of cubes formula, that SOAP formula, is going to be 1 minus the cube root of cosine to the 6th is cosine squared. And then this term squared is 1, plus 1 times cosine squared is cosine squared, plus the square of this term would be cosine to the 4th. So this is good. We've got this thing that we need here. All of this is still over sine squared, but sine squared is 1 minus cosine squared theta using the Pythagorean identity rearranged. So we can cancel those out. So what looked like it was going to be kind of an ugly proof turned out not so bad. So we have 1 plus cosine squared theta plus cosine to the 4th theta, and that part's finished. On to 44. All right, so for problem 44, we've got cosine squared theta over secant theta plus tangent squared theta times cosine theta over 1 plus tangent squared theta. Gets all the way down to just cosine theta. All right, so let's work on this a bit. Remember, look for Pythagorean identities first. So even before you break down into sines and cosines. So let's just leave this. Cosine squared theta over secant theta plus 1 plus tangent squared is secant squared. So that's where I'm going first. Tangent squared theta times cosine theta over secant squared theta. All right, now at this point, if you want to try to simplify things, you can to see what you're looking at. I'm noticing kind of two ways I could go. I could go a common denominator route, or I could see if I have things that cancel here. So let's look at what we have. We have cosine squared theta, excuse me. Instead of dividing by secant, we can say times cosine over 1. That gives me a cosine cubed, which is not quite necessarily where I want to be, but we'll look at what we have. Tangent squared is sine squared theta over cosine squared theta times cosine theta over 1, which is already up there. And then instead of divided by secant squared times cosine squared theta over 1. So this first term, nothing cancels. We get cosine to the 3rd power. Here, cosine squareds cancel, so you're left with plus sine squared theta cosine theta. Remember, if you have exponents higher than 2, you can think about factoring. So this would be factor out of GCF. Both of these terms have a cosine theta in them, which would leave me with cosine squared theta plus sine squared theta. And that's good because that's 1. So this is cosine theta times 1, which is just cosine theta, which is what the right side is equal to. So that proof is finished. Number 45. So 45 is sine to the 3rd theta plus cosine to the 3rd theta. I think we had this on another worksheet. Over sine theta plus cosine theta is going to get us all the way down to, what is this? 1 minus sine theta cosine theta. So again, higher exponents means begin with factoring. So factor the sum of cubes. It's sine theta plus cosine theta. And then this is sine squared theta minus sine theta cosine theta plus cosine squared theta. All of this is over sine theta plus cosine theta. So we can cancel sine plus cosine theta, top and bottom. And then sine squared plus cosine squared is 1 minus, oops, there's no 2 there, minus sine theta cosine theta. And that's what we were trying to show. Okay, 46. So 46 says cosine to the 4th theta minus sine to the 4th theta is going to equal 2 cosine squared theta minus 1. So again, let's begin on the side that has the higher exponents and begin by factoring. So if it's 2 terms and they're both to the 4th power, we should be doing a difference of squares. cosine squared theta plus sine squared theta times cosine squared theta minus sine squared theta. The first set of parentheses is our Pythagorean identity. So cosine squared plus sine squared is equal to 1. Cosine squared theta minus sine squared theta. Again, after this quiz, we're going to learn that that's equal to an identity. But right now we have to show that it's equal to this. So we've done this a few times now on this worksheet. If I only see cosine squared over here, I should sub out this sine squared with its Pythagorean identity. So I don't need the times 1 anymore. Cosine squared theta minus the quantity sine squared, which is 1 minus cosine squared theta. When that negative gets distributed, you get a total of 2 positive cosine squareds minus 1. Okay, 47. 1 minus 2 sine theta minus 3 sine squared theta over cosine squared theta is equal to 1 minus 3 sine theta over 1 minus sine theta. All right, so begin on the more complicated side. And even though I don't see exponents higher than 2, I do see a trinomial here. So that's another indicator to factor. Remember, you can factor this just like what if it were 1 minus 2x minus 3x squared. So you can split 1 into 1 and 1. 3x squared is going to have to be 3x and x, or 3 sine squared, excuse me, is going to be 3 sine theta and sine theta. And you've got to put the plus and minus in the right spot to get minus 2. So if I put a minus here and a plus here, I get minus 3 sine and plus 1 sine, and that's going to give me the minus 2 sine in the middle that I want. So it's factored correctly. Don't forget about the denominator like I almost did. This is over cosine squared. Now, I have the 1 minus 3 sine that I want. How am I going to get rid of 1 plus sine? Use the right side to kind of help you out here. How do I get from cosine squared to something that's 1 minus sine? What if I rewrite cosine squared as 1 minus sine squared? And then that helps because we don't normally do this, but again, looking at the right side, we can factor this into a difference of squares, and that's going to help me cancel. So I've got 1 minus 3 sine theta times 1 plus sine theta on the top. And the denominator is 1 plus sine theta, 1 minus sine theta if I do difference of squares. So these 1 plus sine thetas can cancel, and we're left with 1 minus 3 sine theta in the numerator and 1 minus sine theta in the denominator. And that's what we were trying to prove. Number 48 says tangent x plus cotangent x squared is going to equal secant to the 4th x secant to the 4th x, sorry, lost track of it, times cotangent squared x. All right, so how do we show this? Well, let's keep in mind that secant to the 4th is 1 over cosine to the 4th, and cotangent squared, is cosine squared over sine squared. So maybe for this one, we have 2 options. We can either FOIL right now, like tangent squared plus 2 tangent, cotangent, etc. Or we can add tangent and cotangent together like we've done several times and then square that quantity. And I think I want to go that way because if I add these 2 together, I change them to sines and cosines, and that might be helpful. All right, so let's see. If we add these together, we could get sine over cosine plus, oh, I just realized I changed these to x's. I'm not going to fix that though. They're thetas on your worksheet. Plus cosine x over sine x. We're squaring that. Let's add these together first. This becomes sine squared x plus cosine squared x over cosine x sine x, which is going to get squared. All right, now what about this? We've got 1 over cosine x sine x. All right, so if I square that, I get 1 over cosine squared x sine squared x. And that gets me kind of stuck because I have secant to the fourth times cotangent squared. So what do we want to get here? Let's work on the right side. We want 1 over cosine to the fourth times cosine squared over sine squared. Now this would simplify to 1 over cosine squared sine squared, right? If I canceled these. So use that. Kind of work backwards here. I have 1 over cosine squared sine squared, so what do I want to do? I want to multiply by cosine squared x over cosine squared x because I want to get cosine to the fourth in the denominator, and I'm just kind of working backwards from here. So then that would show that I have cosine squared x on the top and cosine to the fourth x on the bottom. Sine squared x is still down there. Cosine squared over sine squared is your cotangent squared, and 1 over cosine to the fourth is your secant to the fourth. So that one was a little trickier. It would be hard to start on the right side and go backwards because you'd have to kind of know to replace the 1 with the sine squared plus cosine squared. So definitely starting on the left was the way to go for this one. Okay, 49. Secant x plus tangent x equals cosine x over 1 minus sine x. Anytime I see that fraction on the right, I know that somewhere I'm going to be multiplying by a conjugate because this is the one where you're kind of stuck and don't have anything to do. But I'm going to start on the left side and make this 1 over cosine x plus sine x over cosine x. These already have a common denominator, so make it 1 plus sine x all over cosine x. And again, I'm stuck, so what do? I multiply by the conjugate of 1 plus sine x. For two reasons. It's going to give me more work to do so that I have some identities I can work with, but also we want a 1 minus sine x in the denominator, and we just put 1 in. 1 plus sine x times 1 minus sine x is 1 minus sine squared x. Remember, it's a good idea to just show that these two non-conjugates are getting multiplied together, but not actually distribute them. You can save yourself some factoring in the end by doing that, because our goal is going to be to cancel this thing out. 1 minus sine squared is cosine squared x. So showing that allows me to cancel the cosine in the bottom with 1 on top, and I have cosine x over 1 minus sine x, which is the right side of the equation. And our last problem here, number 50, says cosine to the fourth x minus sine to the fourth x should equal, minus 1 should equal negative 2 sine squared x. All right, so let's look at this one. We can't do a difference of squares, and we can't add the 1 to the other side. We can't do a difference of squares here, so what should we do? And this doesn't factor. It's not a trinomial that factors because you have a mix of trig functions. So how about we start with the fact that the right side only has sine squared. So let's begin by getting rid of cosine to the fourth. Now be careful, the Pythagorean identities are only for sine and cosine squared. So let's rewrite this first as cosine squared instead of cosine to the fourth minus sine to the fourth x minus 1. And then now we can replace the cosine squared on the inside with a 1 minus sine squared. So notice that's not the same as me just saying, oh, that's equal to 1 minus sine to the fourth. That's not true. It's not just 1 minus sine to the fourth. It's 1 minus sine squared squared. Minus sine to the fourth minus 1. All right, now if we go ahead and square this out, we would get 1 minus 2 sine squared x plus sine to the fourth x minus sine to the fourth x minus 1. Positive 1 and minus 1 add up to 0. positive sine to the fourth minus sine to the fourth adds up to 0. And that's how I'm left with -2 sine squared x. So if you went through all 50 of these, then hopefully you notice there are a lot of really common things that we do over and over and over. If you feel like you need more practice and you haven't gone through all 50, I would suggest keep going, skip around if you need to. And remember, we had 3 other worksheets that you can practice with to keep redoing identities. There are no brand new problems on tomorrow's quiz. I just picked problems that we've done and or very, very similar to what we've done and put them on there. So you can't memorize them all, but you can practice them a lot and start to see some common patterns.